Hello students, we were doing determinants by using properties. Let us start with our question. If x is not equals to y, not equals to z, then and x, y, z determinant of this is equals to 0, then prove that x, y, z is equals to -1. Now, in the third column, the term is sum of two terms, so we can write it as x, y, z, x square, y square, z square, 1, 1, 1, x, y, z, x square, y square, z square, x cube, y cube, and z cube. Now from the second determinant, take x, y, and z common. First determinant, as it is, x, y, z, x square, y square, z square, 1, 1, 1. By taking x common from R1, y from R2, and z from R3. Here we have left with 1 x, x square, 1 y, y square, 1 z, z square. Now here interchange second and third column. So negative sign here, 1, 1, 1, x square, y square, z square, plus x, y, z, 1, 1, 1, x, y, z, x square, y square, z square. Now interchange these two columns C1 and C2. Again negative sign. Negative is already outside the determinant, so negative and negative plus, so it becomes 1, 1, 1, x, y, z, x square, y square, z square, plus x, y, z, 1, 1, 1, x, y, z, x square, y square, z square. Now these two determinants are same, so we can write it as 1 plus x, y, z, 1, 1, 1, x, y, z, x square, y square, z square. Now we will have to solve this determinant. Operate R2 as R2 minus R1 and R3 as R3 minus R1. 1 plus xyz, 1 x square. Subtract the terms R2 minus R1. 1 minus 1, y minus x, y square minus x square. 1 minus 1, z minus x, z square minus x square. Now instead of this, we will use the formula a square minus b square, that is equals to a minus b and a plus b. Now take y minus x common from the second row and z minus x common from the third row. Note up to here. Then what we get? 1 plus xyz. Take y minus x common from second row. Z minus x from third row. 1 x square. Y minus x is common. A square minus b square is a minus b, a plus b. Y minus x, y plus x. Y minus x is common, so here we have left with y plus x. 1 z plus x. Z plus x. Now expand the determinant by using the first row or first column. First column we have 2 zeros, so expand it along first column. 1 plus xyz, y minus x, z minus x, 1 into 1, 1, y plus x, z plus x. We have expanded it along the first column. Next two terms will be 0. 0 into something is 0. So 1 plus xyz, y minus x, z minus x. Solve the determinant z plus x minus y plus x. So here we have left with z minus y. 1 plus xyz, y minus x, z minus x, z minus y. z. Now this determinant is equals to 0. We have given this. This determinant is 0 means any one of these terms should be equal to 0. Then only the product of these terms will be 0. If we put x minus y 0, then x is equals to y. If we put y minus z as 0, then y is equals to z. And z minus x 0, then z is equals to x. But x is not equals to y, y is not equals to z. So only the term which should be equal to 0, that is 1 plus x y z. So x y z is equals to minus 1. X y z is equals to minus 1. Note it down. Now the next question is, for any scalar p, prove that this determinant is equals to this. This is same as the previous question. Only instead of xyz, we get here p into xyz. So you can try it by yourself. Now the next one is question number 25. Note this statement. Now next question is, write down the statement. Using properties of determinant, show that 1, 1, 1, a, b, c, a square minus bc, b square minus ca, c square minus ab is equals to 0. First, this is the sum of two terms, so we have to separate these terms. 1, 1, 1, a, b, c, a square, b square, c square plus 1, 1, 1, a, b, c minus bc minus ca minus ab. Now in the second term, multiply and divide it by a, b and c. Multiply the first row by a square minus abc. Second row by b square minus abc. Third row by c square minus abc. So 1, 1, 1, a, b, c, a square, b square and c square. Now take minus abc common from the third column. So minus abc upon abc, abc, a square, b square, c square, 1, 1 and 1. 1, 1, 1, a, b, c, a square, b square, c square. Now interchange second row and third column, then negative sign here, negative is already there. So minus minus plus, a, b, c, 1, 1, 1, a square, b square, c square. Now interchange c1 and c2. So first determinant is 1, 1, 1, a, b, c, a square, b square, c square. Again negative sign, plus minus minus, 1, 1, 1, a, b, c, a square, b square, c square. square. Determinant of this term minus determinant of this term, these terms are same. So determinant of these terms will get cancelled. So it is equals to 0. Note it down. Now next one is question number 26. Write down the statement. If m belongs to natural number and m is greater than equals to 2, prove that 1 MC1 MC2 1 m plus 1 C1 m plus 1 C2 1 m plus 2 C1 m plus 2 C2 is equals to 1. Now we have one property, that is NCR plus NCR plus NCR minus 1 is equals to N plus 1 CR. We will use this property in these two terms. So write down 1 MC1 MC2 1 m plus 1 C1 m plus 1 C2 n plus 1 CR m plus 1. So n is m plus 1, m plus 1 CR is 1. So 1 minus 1 0 m plus 2. So m plus 1 R is 2 and 2 minus 1 is 1. Note up to here. After that, operate C3 as C3 minus C2. 1 MC1 MC2 1 m plus 1 C1 m plus 1 C2. C3 minus C2 1 minus 1. This term will get cancelled. M plus 1 C0 m plus 1 C1. Now again apply this identity on C2 terms, these two terms. So it becomes 1 MC1 MC2 1 0 m plus 1 C0 m plus 1 C1. Now R is 1 here, n plus 1, so n is m. So m C1 plus 1 minus 1 is 0. Here again m C2 plus m C2 minus 1 is 1. Now apply the operation C2 minus C2 as C2 minus C1. 1 minus 1 0 MC1 MC2. MC1 will get cancelled. So MC0 MC1 m plus 1 C0 m plus 1 C1. Now expand the determinant along the first row. What we get? 1 into MC0 MC1 m plus 1 C0 m plus 1 C1. 0 into something is 0. Now MC0 and m plus 1 C0 has value 1. So put these values. 1 1 MC1 m plus 1 C1 m plus 1 C1. So m plus 1 C1 minus m C1. This has value m plus 1 and it has value m. So answer is 1. We are n factorial upon r factorial and minus r factorial. So solve this by using this formula. Note it down. Now next one is question number 27. Evaluate the determinant 10 factorial, 11 factorial, 12, 10 factorial, 11, 12, 11 factorial, 12 factorial, 13, 12 factorial, 13 and 14 factorial. Now we can write it as 10 factorial. We can write 11 factorial as 11 into 10 factorial and 12 factorial as 12 into 11 into 10 factorial. Similarly for this 11 into 10, 12 into 11 into 10, or we can write it as 12 into 11 factorial. To take 11 factorial common, 12 into 11 factorial, 13 into 12 into 11, 12 factorial, 13 into 12 factorial, 14 into 13 into 12 factorial. Now from R1, from row 1 take 10 factorial common, from row 2 11 and from row 3 12 factorial common. So we have left it with 1, 11, 12 into 11, 1, 12, 13 into 12, 12 factorial common, 1, 13 and 14 into 13, that is 182. Now operate R2 as R2 minus R1 and R3 as R3 minus R1. 10 factorial, 11 factorial, 12 factorial, 1, 11, 132, 1 minus 1, 12 minus 1, 156 minus 132, 1 minus 1, 13 minus 11 and 182 minus 132. Now expand this determinant along the first column. 10 factorial, 11 factorial, 12 factorial, 1 into 124, 250 minus 0 plus 0. So 10 factorial, 11 factorial, 12 factorial, 50 into 1, 24 into 2, 48. So 2 into 10 factorial, 11 factorial and 12 factorial. Note it down. Now the next question is question number 28. Write down the statement of next question. Note it down. Prove that determinant of x plus y, x, 5x plus 4y, 4x, 2x, 10x plus 8y, 8x, 3x is equals to x cube. Prove that determinant of this is equals to x cube. Now in the first column, the terms are in sum of two terms. So separate these terms first. X, 5x, 10x, x, 4x, 8x, x, 2x, 3x, plus y, 4y, 8y, x, 4x, 8x, x, 2x and 3x. Now take x common from 3 rows, R1, R2 and R3, so it becomes x cube. 1, 5, 10, 1, 4, 8, 1, 2, 3. Take y common from the first column, x common from second column and third column. So 1, 4, 8, 1, 4, 8, 1, 2, 3. Here C1 and C2 both are same, two columns are identical. So value of this determinant is 0. Y x square into 0. And here we have x cube, 1, 5, 10, 1, 4, 8, 1, 2, 3. Now in the next step, apply C1 as, operate C1 as C1 minus C3 and C2 as C2 minus C3. So x cube, C1 minus C3, 1 minus 1, 5 minus 2, 10 minus 3. C2 minus C3.